Good morning, everyone. I would invite Himanshu sir to start the session.
Good morning, everyone. So today we have to start the new chapter, that is some basic principles and techniques in which we have to concentrate on the qualitative and quantitative analysis. And qualitative and quantitative analysis, we have to first go for the purification method. Okay. So do you know anything about purification? Why we are doing purification of the organic compounds? Anyone? See, basically, we know about that. Whenever we are extracting the organic compound, they are not generally pure. They're not generally pure. They have certain impurities with them, and for that contamination portion, the other two products which are desirable, or you can say the products which are need to be extracted are not pure. So we are using certain methods so that we can pure the compounds. So if you can see my screen, let me play this particular PPT. So this is the organic chemistry basic techniques in which we are talking about the criteria for the purity of organic compounds, in which we have certain criteria in which you can say two things are most important. First, you'll go for the boiling point, and second, you'll go for the melting point. Okay. Uh, First, can you tell me what is boiling and what is boiling? I told you earlier also. See, when the atmospheric pressure and the vapor pressure of the liquid become equal, when the atmospheric pressure and the vapor pressure of the liquid become equal, that is known as what? Boiling. So, in the purity, what we are doing, we are calculating first the boiling point and the melting point. Pure solid melted at a definite temperature, pure liquid has a definite boiling point. So, we have certain, you know that if I'm talking about water boiling point is 100 degrees Celsius, freezing point is 0 degrees Celsius, same we have melting points. Okay, so this is the criteria of purity. First we'll discuss about the melting point determination. Okay, so you can see in this particular portion what is melting point, the temperature at which the solid changes into its liquid form. This, when the solid starts changing into the liquid form, that particular case is known as what? Melting. And the temperature at which it happens, that is known as melting point. So how you will determine the melting point of any compound is, first you will take this capillary tube in which the sealed end is present at the bottom, in which what you have to do, you have to put the substance of which you want to calculate the melting point. Okay, the one end is sealed, another end is opened up. Now what you'll do, you'll bind up a thermometer with the help of a thread. You'll bind a thermometer, and then what you'll do, you will take the Thales tube in which the paraffin oil is present, and you'll put that thermometer along with that substance inside this, and you'll start heating it, and when you'll see that there is a rise in temperature in the thermometer, and by that you can calculate the melting point of the compound. So what you have to do, first you have to take the compound in a tube, capillary tube. You have to bind the capillary tube with the with the with that particular thermometer. You have to bind with the thermometer. Then you have to put in a Thales tube in which there is a capillary along with the thermometer is present. You are continuously heating it, and then you will measure the temperature. Okay, determination of boiling point. What you have to do? What is boiling point? The temperature at which the vapor pressure of the liquid become equal to the atmospheric pressure. I told you earlier when I was teaching the chapter that what is boiling? Boiling is the condition at which the vapor pressure of the liquid is will become equal to the atmospheric pressure. So that condition is known as boiling, and the temperature at which the boiling start is known as boiling point. The temperature at which the boiling start, that is known as boiling point. So first we have to take a fusion tube. Inside the fusion tube we have capillary, open end, sealed end, Okay, then you have to bind it again with the thermometer. Okay, with the help of thread you can bind it. Then you'll go for again same Thales tube, paraffin oil, put that particular setup in the tube, and then you'll start heating it. Again, just note down the temperature. Next is method of purification of organic compounds. So for the method of purification of organic compound, we have certain criteria. For example, first we have sublimation, second we have crystallization, third we have distillation, fourth we have differential extraction, and then we have chromatography. So can anyone tell me what is sublimation? What is sublimation? But no one knows what is sublimation. See, when the solids start converting directly into the gas form, that is known as sublimation. So, about to our method used for the solids, and then we are using for the liquids. So, first, let's talk about the sublimation. Sublimation, the process when the conversion of a solid into the gas. This is not important that much. So, we are talking about changes from solid phase to the vapor phase, in which what you have to do, you have to remember that there is no liquid phase in the mid. What is the easiest to separate the sublimable compound from the non-sublimable compound. So we are using this particular technique. The principle is that one of the compound must be sublimable, or the compound must be contain the impurities. So if you can see the setup, if you can, we have to do, for example, sublimation of dry ice, iodine we can use. But in this particular method, you can see we have one funnel, we have watch glass, okay, we have iodine crystals along with the impurities, and cotton wool is present at the above. So you can see method of purification. Wait, just give me 1 minute. So sublimation, I think probably you guys know. You don't have to do a lot. Just use. Okay, I'll show you sublimation in a very. Okay, for the sublimation, what you have to do, you have to take a particular. You can use any of the things. Sometimes we can take petri dish. Sometimes we can use any of the thing in which you are putting your impurity sample. Above which just add a funnel in an inverted position. Here just add cotton wool. This is cotton wool. This is funnel. This is you can say what you guys use, petri dish. Okay, or you can use any of the substance in which the crude substance is present. Crude organic compound is present. Okay, then heat it from the bottom. But you'll see there are two type of substance. One is sublimable, another one is non-sublimable. So the compound which is sublimable will start converting into the vapor form, and you'll see there's a deposition at the top of this particular funnel. So you can this is known as sublimate. This is known as sublimate. So what we can do, we can use we can separate the non-sublimable compound from the sublimable compound. So this is the particular method which we use for the sublimation. Okay, I think sublimation is clear. See, so we have two methods now. We have organic and inorganic. We have crystallization and fractional crystallization. If I talk about the crystallization, what you have to do, obtaining solid in pure and crystalline form from the solution. This in crystallization, what you have to do, you have to obtain the crystals. So can anyone tell me the shapes of the crystal? Basic shapes. Yes, anyone? Huh? No, you're not audible. Anyone else? Shape of crystal. No one knows. See, I'll tell you one trick. If no one knows, you can use a word cute mother. Cu, cubic, Te, tetrahedral, Mo, monoclinic, T, triclinic, He, hexagonal, and R for the rhombic. So this is a particular way you can learn cute mother, cubic, tetragonal, monoclinic, triclinic, hexagonal, rhombic. So these are the shape of crystals. See, you need to revise your 9th and 10th first. Okay. For the crystallization, we have to obtain the pure and crystalline form from its solution. What is the principle behind it? See, in all these methods, you have to remember the principle main thing. Okay, with the example, that's it. No one gonna ask you about the diagram. No one gonna ask you about the uh, other thing, that what is this known as, what is this known as. For example, giving diagrams. Nothing such sort of question is asked. So just concentrate more on the principle. So substance is more soluble in a given solvent at a higher temperature than at a lower temperature. So substance which is more soluble, okay, will make out the crystal while rather will rest. So this is a particular method. You can see in this particular method what we have a solution with the insoluble impurities, hot jet, we are heating it, glass funnel, filtrate. So what we are doing, we are pouring up the solution in this particular funnel, and the filtrate will come down and will get a sort of substance. And unorganic chemistry, what see certain criteria what we have to take is like, first is the compound which have to be crystallized is either more soluble at high temperature, or there is a possibility it can be least soluble at a high room temperature. Second thing, impurities are generally sparingly soluble, you can say insoluble. Okay. Third thing, solvent, they must no reaction with compound to be purified. Fourth thing, what you have to remember, solvent must have low boiling point so that it can be easily removed, while the solvent must have low viscosity. So let me tell you first fractional distillation. Okay, so the fractional crystallization. So in the fractional crystallization, what you have to do, there is a separating component of a mixture of two or more solids having different solubilities in the same solvent. Having different solubilities in the same solvent at a temperature by stepwise crystallization. For example, which are more soluble will make out the crystal first. Okay. Oh, sorry, which is least soluble will make out the crystal first. Okay, so like a least soluble substance crystallizes out the first, then we'll go for the recrystallization, then more soluble compound will crystallize out. So sort of what you have to do in this particular method, see, I told you this method is particularly used for to purify two or more compound, which have different solubilities, and what we do a repeated crystallization here. Repeated crystallization. So first of all, you have to make a saturated solution. First, you need to know what is saturated solution. What is saturated solution? We generally learn these terms in 9th and 10th standard.
The limit of solution get into uh, solid, sir.
See, we have a certain limit above which the more solute cannot be dissolved in it. For
Yes, sir.
example, I have one beaker and 50 ml of water is there, and I'm just pouring out sugar. Okay, so there will be a certain limit at a particular temperature. The temperature is fixed, and there's a limit that how much sugar can be dissolved. For example, 200 gram of sugar is dissolved. 200 gram of sugar is dissolved. Above which the more sugar cannot be dissolved at this particular temperature. So, so that solution which is formed is known as saturated solution. So, what you have to do, you have to take but hot saturated solution of the mixture. First of all, you have to take hot saturated solution, okay, which is then allowed to cool, okay. Then what you will see, the less soluble substance or compound will crystallizes first, okay. Then what the remaining thing which is left is known as mother liquor. For example, the two A and B, two things are present. A has the less solubility, so it will form the crystal first. So when it form the crystal, the remaining liquid of B is known as what? Mother liquor. So this mother liquor is again get concentrated. It again get concentrated. When it get concentrated, it again allowed it to heat, then followed by the cooling, then followed by the crystallizing. So the method will be same. First, two or three compounds. First, with the less soluble, make the saturated solution, heat it, then cool it down. The less soluble will make out the crystals. Then the remaining is known as mother liquor, which is then again concentrated out, then heat, then followed by the cooling, then again crystallization. So this just because we are doing in a form of fraction, small fractions, we are making out the crystal. That's why it is known as fractional crystallization. Okay, clear? Yes or no?
Yes, sir.
Okay, let's come back to this PPT. So let's first thing, I mark the answer. This is not a big deal. Criteria for the purity is solubility. First, the compound must be soluble. Okay. Second thing, which of the following compound is amorphous substance? Amorphous means general form is present in the form of uh, not in the liquid form or generally in the powder form, that is glass. So you can see the example. I'll share this PPT later on. Okay, the next is distillation. See, what is distillation? Liquid is converting into the vapor phase at its boiling point. The liquid, we are converting the liquid into the vapor phase at its boiling point, and the vapor is then condensed back to the liquid on cooling. So the principle what is behind this distillation is that it involves the both evaporation of a liquid and condensation of its vapor. The, in distillation, two processes occur simultaneously. First one is the evaporation. Second thing is condensation, or you can say first vaporization or then condensation. Okay, so let's talk about the simple distillation first. So in simple distillation, you can see we have a round bottom flask in which the impure liquid is present. We have the impure liquid is present, below which we have a wire gauge, so that direct heating is not there. Uniform heating is present. Then above it we have a tripod. Below it we have a tripod stand, inside which we have a Bunsen burner. And in the round bottom flask, you can see we have a thermometer attached, so that we can we can see the temperature. So now what will happen? You can see at the right side there is a tube which is there's a condenser. Okay, so in this condenser we know that one inlet and one outlet is present. Okay, one inlet and one outlet. Out in from the inlet, the cold water will be will come inside the condenser, while from the outlet or where the living water condenser is written, beside it you can see there is a outlet to the sink, and in which what exactly happened, there is a removal of the hot water. So now what the process is again, the process sort of like, the round bottom flask is containing the impurities. Okay, there was a wire gauge here, Bunsen burner, and you can see here a thermometer is attached for checking the temperature. Now you can see with this particular round bottom flask, we have a condenser here. My drawing is not that much good. Okay, very bad. So you just understand. That's why I'm showing the diagram. So this is two taps are present, or it's like this in the diagram. So it will be to the sink, and it will be this is the inlet. This is from tap. Okay, this is outlet. This is inlet. Okay, and inside this there's a tube. So what will happen when the vapor is formed? The vapor will come to this condenser. So how condensation occur? Condensation occur at a room that a low temperature. When you provide the low temperature to the vapor, they start converting into the liquid form. So the vapor inside this particular tube, just because of the cold water, this is cold water, this is hot. Why this is hot? Just because the cold water is just making this vapor converting into the liquid form, and all the water get heat up, and it will move out from the outlet to the sink again. And here you can see we have a flask in which we'll get a pure liquid. So that's a sort of condition in which we are doing the separation of the two compounds, in which one is having a low boiling point, will separate out first, while the remaining will stay in the round bottom flask. I don't think that you guys don't know it. It's very easy. Next is fractional distillation. See, if I talk about the fractional distillation, separating and purifying the component of mixture of two or more miscible liquid having different boiling point. What is miscible and what is immiscible? What is miscible and immiscible? See, miscible which can be easily mixed inside within each other, while immiscible which do not mix. For example, oil and water are immiscible, and water and alcohol is miscible. Water and milk is miscible. Whatever you can take. Okay, polar dissolve each other, non-polar dissolve each other. Okay, so for the what is the principle? More volatile liquid distill out first, leaving behind the less volatile liquid. Volatile are those compounds which convert into gaseous form at the room temperature. So if they are converting into the gaseous form at room temperature, but if it'll give more heat, then they will definitely convert fast into the vapor phase. So in this particular method, you can see the diagram. Same, for example, we are taking a mixture of acetone and benzene. Okay, and what we are doing, we are heating it. Okay, so the vapor of two things will form. Either it will be of acetone, either it will be of benzene. Okay, so the component which is less volatile will remain at the bottom of the fractional column, while the one having more volatile character will come at the top of the fractional column. Okay, so just a simple is the column you can see is like this. Okay, so just remember this thing. and here we have the same round bottom flask. Okay, so the component which is more volatile, will just separate out first, while the component at the less volatile will be at the bottom of this fractional column. Okay, so just because we are using the fractional column, rest thing is same as the crystallization. As the simple distillation. Rest thing is same. Just remember just because we are using the fraction in this particular method, that's why fractional column, that's why it is known as fractional distillation. If I talk about the application of this particular fractional distillation, sometime application can be asked. If I talk about the application generally they are used to separate the crude oil. What is crude oil? Anyone? What is crude oil?
Extraction from that
Yes. And what we get from the crude oil? What are the products?
petroleum, petrol, kerosene.
Yeah, kerosene, gasoline. For example, what it contain? It contain gasoline. It contain kerosene. It contain diesel. What else? Lubricating oil. So we have certain other products also. So I'm writing etc. here. Okay. So these are the generally we used to use this fractional distillation method for the separation of the component from the crude oil. Second thing, generally we are using for destructive distillation of wood. The method this is used for destructive distillation of wood. Okay, so generally we used to separate methyl alcohol and acetone. Okay, so there's a acid known as pyrogenous acid. Okay, that pyrogenous acid contain acetone as well as methyl alcohol. All right, there's acid pyrogenous acid. This acid contains two things, acetone and methyl alcohol. If I talk about the boiling point, acetone have boiling point 329 Kelvin, while methyl alcohol having the boiling point 338 Kelvin. So for the separation, for this district, we do destructive distillation of wood for this pyrogenous acid, and we get acetone as well as the methyl alcohol. So for forming the wood spirit, we generally use it. Okay, so this was in the case of fractional distillation. See, you can see the fractional column. We have different type of fractional column also. Okay, organic. Let's talk about the under the reduced pressure. So everything is same. Okay, first is the principle. Okay, by lowering the external pressure, the boiling point of liquid can be decreased. Just this factor we are using here. We know that generally we know the boiling point. Generally, what is the definition of boiling point? Then when the vapor pressure of the liquid become equal to the atmospheric pressure. Okay, so if I lower down the vapor pressure, will attain a boiling point faster. So distillation under reduced pressure is generally used for the purification of liquid that have high boiling point and decompose it at or below their boiling point. So generally we are using sort of this type of compounds which are having the high boiling point. So just reduce out the boiling point. They will form in the vapor phase fast. So you can see we have a manometer over here attached with the vacuum pump so that the vapor pressure can be reduced. If you reduce the vapor pressure, the boiling of the component will be more faster as compared to the normal condition. So when the vapor pressure will be low, boiling will attain more faster, the separation will be faster. I don't think that this is that much important. This much is sufficient for this particular method. Then let's talk about the steam distillation. Okay, for see, in the steam distillation, what we used to do, we have first forming the water vapors. So in this particular method, what we do, we used to transfer the vapor form of water to the second round bottom flask. So you can see from the first round bottom flask, what we are doing, we are heating up the water molecule. We are heating up the water molecule, and the water molecule is then heated, and the vapor is formed, is transferred to the another round bottom flask, which contain the component which is need to be distilled. It means a separating mixture. You can say inorganic compound. Okay, so sometimes we can use generally the compounds in these. See, you know one thing, that organic compound contain the carbon. They don't mix with the water generally until unless they are having a hydrogen bond. Okay, so these water and this component will present in the second bottom round bottom flask. Will heat this particular round bottom flask. You will see again one water inlet and one to the sink is going. Inlet water, cold water will come. Outlet, hot water will go out. The compound start converting into the gas, or you can say vapor form, and you can see the pure organic compound will be get separated. But what exactly happen here, that the organic compound will convert into the vapor phase. Along with that, in this condition, we have water molecules also. See, you can see at the last, there is at the lower surface, we have the distilled liquid of organic compound, but above which we have a layer of water molecules. Just because in this particular method we are using the water also. So this particular method is we have certain component of water also, but main thing is in this particular method water can be easily separated just because they are immiscible. Okay, so the method is used for the converted into the vapor phase, and the vapor phase is condensed back to the liquid is called distillation. We have discussed when the difference between the boiling point of the immiscible liquid is less than 30, then we are using the fractional column. Why fractional column? Because the more volatile compound will remain at the top, while the less volatile will remain at the bottom. Okay, next one is the purification of liquid with very high boiling point can be carried out by those having the high boiling point. But what we do, we used to reduce the vapor pressure, and when the vapor pressure reduced, the boiling will be low, so we are using distillation under the reduced pressure. The next which type of column, see name you can remember from there, Hempel's column. Then let's talk about the chromatography. Okay, so the chromatography, if I talk chromatography, before chromatography we also have differential extraction. Just give me 1 minute. Okay, we have one more method which is not in this PPT. See here, one more method is there, that is differential extraction. Differential extraction. Anyone know what is differential extraction? See, generally, this method is used to recover the organic compounds. Recover the organic compounds from the aqueous solution. We know that the organic compound will not dissolve in the water. So for the separation of the organic compound from the water or aqueous solution, we use this particular method. Okay, so what we use in this particular method, we have a separating funnel. Separating funnel you'll see like this in the lab. So what you will do in this particular method, this is a lid over here. Okay, just remove it and put the organic compound with the water. For example, I'm taking oil plus water. You know that oil and water do not mix. So I'll put the oil and water here, and you will see what you have to do. You have to do the shaking. Just shake this. This instrument is known as separating funnel. Separating funnel. So you have to shake the separating funnel, and after that you'll see two layers will form. One will come at the bottom while the other will remain at the top. So this is layer A and this layer B. So the two layer will form. After first we have to shake it, then leave it for a time. You'll see two layers will form. One having a component, organic component, another having the aqueous solution. Then what you will do? You will open up the tap at the bottom, and you'll separate the first layer, then second layer. So this is a simple method in which organic compounds generally form layer here, that above one, and at the bottom we have aqueous layer. So generally this method is used for the separation of the method which are immiscible liquids. Okay, for the immiscible liquid. Clear this much? Differential extraction.
Yes, sir.
Okay, sometimes what exactly happen? Certain amount of substance is left, so you have to repeat the process. You have to repeat this particular process 2 to 3 times, so that you'll get every drop of the method, every drop of the compound cell. Okay, so let's start with the chromatography. Earlier it was known as chroma plus graphy. It means we are separating the mixture on the basis of color, just because the chroma represents the color. So two things are there. One is mobile phase, another one is the stationary phase. If I talk about the stationary phase, as the name suggests, it means the compound is not moving. It's a stationary. Okay, so the any of the mixture which is showing affinity with the stationary phase will remain as it is, while the one showing the affinity with the mobile phase, mobile means moving, the showing affinity with the mobile phase will separate out. So we have two phases. One is the stationary phase, other is the mobile phase. First, let's talk about the adsorption chromatography. Principle is differential absorption. Component, the different compounds are adsorbed or the adsorbent to different degrees. First, tell me the difference between the adsorption and absorption. First, the difference between the adsorption and absorption. AD and AB. Anyone? No one knows about the absorption and adsorption. Okay, listen. See, when we are talking about the bulk, we say it as absorption, AB. If we are talking about the surface, we say it as adsorption. Okay, so for example, we can take a sponge. When the sponge is kept inside the water, it absorbs the water. So water is coming in the bulk. So if it is coming in the bulk, it is known as absorption. But same that sponge is kept in a room, and we have certain amount of, you can say, certain amount of dust is present at the surface. So when it is on the surface, not in the bulk, we say it as adsorption, AD. So we have two things, adsorption and absorption. Absorption, the bulk phenomenon, adsorption, the surface phenomenon. So the principle inside the chromatography is the adsorption. So the first type we are taking as column chromatography. So inside the column chromatography, what you have to see, we have a stationary phase that is known as adsorbent here, okay, and a mixture of A, B, C compound. So the which have more affinity with the stationary phase will remain in the column, while the one which have the less affinity will come at the bottom. So this is a particular matter. Generally the thing what we use in the column chromatography, inside the column we say it as matrix. What we say? We say it as matrix. Okay. So here we can see the component C, component B, and component A. C is coming down. It means the C is weakly adsorbed. In the B condition, less adsorbed as compared to the C. More adsorbed as compared to the C and less adsorbed as compared to the A. So we have three phase over here. See, this was the column, okay, and here we have adsorbent inside it, okay. Generally we use here glass wool also, so that the matrix whatever is filled inside it will not go down. And we have three. This is the C1, this one was B, and this one was A. So the C phase is showing less affinity, so it will come down first. We'll separate it, okay, then B1, then A1. So generally we use this method for the separation of the component which is showing more affinity with the stationary phase. So component A was strongly adsorbed, component B you can see moderately adsorbed, component B is moderately absorbed, and component C is weakly adsorbed. Okay, clear this thing? So this is column chromatography. Okay. Probably I think you'll learn this thing in bio also. So this is thin layer chromatography, inside which what we have to do, you have to put the solvent at the bottom, okay, and you'll use a TLC plate, that is thin layer chromatography plate, inside which you have to create a baseline, and in the baseline you have to mark about the spot of a sample, just a simple spot of the sample. If the condition is if the solvent, if the mobile phase is solvent over here, okay, if the sample contains the component which show affinity with the solvent, it will move. The rest, it will remain as it is. So for the visualization method, I'll explain this method. See, you can see in thin layer chromatic, you see the baseline was at the bottom here, red dot. That's for the sample. Just because it is moved with the solvent, you can see, you can calculate what was the baseline, and solvent moved up to the y distance while the spot moves up to the x distance. Okay, so what is the retardation factor? Retardation factor is the ratio of distance traveled by the solute from the baseline divided by the distance traveled by the solvent from the baseline. So RF value, how you can calculate? You can put the value of x and y. X is the distance of the spot from the baseline, while y is the movement of the solvent from the baseline. So you can divide it, you can calculate the RF value. Okay, generally this method is used for the separation of the dyes and all. Okay, so for the identification of this particular method, I'm not writing here. For the identification of the method, we generally use ultraviolet light, iodine vapors, and chemical methods. Okay, so just remember this thing. Then let's talk about the partition chromatography, and in which we have to study about the paper chromatography. See, it's just same, nothing much difference in this chromatography method. Same baseline, sample spot, but instead of using a thin layer chromatography plate, what we are using here, we are using the chromatography paper. Okay, so we are using the chromatography paper. Generally, this chromatography paper is made up of the cellulose. So let's talk about this chromatography. So in the paper chromatography, we are using the paper we use as cellulose paper. Cellulose paper, okay, and two things are present: stationary phase and mobile phase. Mobile phase is solvent. Wait. See, the station. Sometimes people say that a stationary phase is a cellulose. Stationary phase is not the cellulose, but the water which is absorbed, or chemically bounded to the cellulose. Okay, in the stationary phase, the water which is adsorbed or the chemically bounded with the cellulose, that is known as the stationary phase, while the mobile phase is solvent. Okay, so what is the principle? Principle is the partition. You can directly say. What is the principle of the paper chromatography? That is partition. The one showing more affinity with the mobile phase will move up, while the one which shows the less affinity with the mobile phase will remain at the down. So you can see, same as in this case, we are calculating the RF. You can calculate the RF over here also. Same thing will happen. Just change the paper. So some questions. The principle of the column chromatography is adsorption. Okay, not the absorption. Okay, the relative absorption of each component of the mixture can be used by RF value X upon Y. Which of the following is a type of partition chromatography? That is paper chromatography. Okay, so these are the simple purification method which we use for the detection of the organic compound. So is this clear?
Yes.
Okay, so let's start with the qualitative analysis. And we'll do one analysis today, then rest we'll do tomorrow, and probably tomorrow or day after tomorrow the chapter will be done. Okay, so this chapter is very small, probably 2 to 3 classes I'll take, that's it. So what the first is the determination of or detection of carbon and hydrogen. Detection of carbon and hydrogen. So what we do, we take a test tube. Okay, and in test tube, what we have organic compound in which we need to check whether the carbon and hydrogen is present or not. Organic compound with cupric oxide. I have mentioned here what is organic compound with the cupric oxide, that is CuO. Okay, CuO. Then we have a stopper over here, a delivery tube containing a bulb at the bottom, at the top. Then it will move further into the another test tube, and this test tube contain lime water. Okay, and this bulb contain anhydrous copper sulfate. This much is clear. Test tube which is continuously getting heated. Okay, test tube which is getting continuously heated contain the organic compound with the cupric oxide. This bulb will contain the anhydrous copper sulfate, and again the another test tube that is called in that particular test tube we have lime water. So what will happen? See, if the organic compound contain carbon, it react with the copper oxide, cupric oxide. It will form, on heating, it will form carbon dioxide plus copper. If hydrogen is present, it will react with copper oxide, and on heating it will form H2O plus CO2. So we need to check whether the compound is formed or not. Okay, so we know that anhydrous copper sulfate is white in color. Anhydrous copper sulfate is white in color. But see, when the carbon dioxide and water is formed in this particular reaction, they will go here. Carbon dioxide will move forward while the water molecule will get absorbed by anhydrous copper sulfate. And when this anhydrous copper sulfate absorbs the water molecule, it changes its color from white to blue. The reaction it follows is CuSO4 plus H2O, 5H2O. It forms CuSO4 dot 5H2O. So copper sulfate in anhydrous condition was white, but when it absorbed the water of crystallization, then it converted into the blue. So you'll see, you can detect, yes, there is the presence of hydrogen. Just because water is formed, it means hydrogen was present in the organic compound. Okay, what will happen when the carbon dioxide moves to the lime water? This is a basic question, just tell me.
It will become white color, sir.
Milky white, sir.
It will become milky white. So what is the formula of lime water? That is CaOH whole twice. When it react with the carbon dioxide, it will form CaCO3 plus H2O, and this CaCO3 form milkiness. So this lime water will turn into milky. So you can see that we have deducted that the organic compound which we were having contain carbon and hydrogen. Got it? Got it or not? Any question from this detection of carbon and hydrogen?
No.
No? Okay. Let's talk about the another detection, that is detection of nitrogen. And detection of nitrogen, where I'll use Lagrange's test. Okay. So for this test, what we have to do, we have to make the Lagrange extract first. So I'll tell you the extract formation first today. Then we'll use the detection method tomorrow. Okay, I'm telling you only the method how you can make the extract. So for the preparation of extract, what you have to do, I'm writing the step. First, you have to take a freshly cut sodium, not a big, you can say pea size only. Okay. Second thing, okay, I'll make a sort of this. Wait. Second thing, what you have to do, you have to heat it. Heat in fusion tube. Okay, when you will start heating, shining globules will form. Okay, so what we are doing, we are taking a small piece of sodium which is gently heated in the fusion tube till it forms the shining globules. Now the tube, you have to remove it from the flame. Now remove the flame. Now when you remove the flame, what you have to do? Add the organic compound. Which organic compound? Which you have to, in which you have to extract the amount of nitrogen. So add the organic compound. Okay. Then again heat, but heat till it, okay, till it become, till it become red hot. Okay, till it become red hot. Then what you have to do? Then what you have to do? You have to uh, that you know what is China dish? A sort of this. Okay, so that plunked that tube into China dish in 10 to 15 ml of distilled water. When you're done with it, then boil the content. When you'll boil it for few minute, then cool it, then filter it. The filtrate is known as Lissange's extract or sodium fusion extract. So what you have to do, first take this small piece, pea size, not bigger, that pea size freshly cut sodium, heat it in the fusion tube till it forms the shining globule, then remove up the flame, add the organic compound in which you have to detect the nitrogen, then heat it till it becomes the red hot. Approximately you have to heat it around 2 to 3 minutes. Okay, not more than that. So you'll see in 2 to 3 minutes, you'll see it will convert into red hot. Then just break that, plumb that into the China dish. But into 10 to for 10 to 15 in 10 to 15 ml of distilled water must be present in the China dish. When you plumbed it, then boil the content. Let everything will be inside that China dish. Uh, Boil it, cool it, then filter up the solution. When you'll filter it, the extract what you get, that is known as Lissange's extract or the sodium fusion extract. So tomorrow I will ask the process how you make this extract. Then we'll go further. Just because we have to use this particular extract in many of the reactions. Okay. So tomorrow we'll finish with the detection of the sodium, detection of the halogen, detection of the nitrogen, detection of the halogens. Okay, we'll go for that also. So just revise whatever I taught you today, and we'll see you in the next class. Okay, if you have any doubt, you can ask me in the next class. Just revise first this class, then we'll move further. Tomorrow we will start with the extraction of the nitrogen or detection of the nitrogen first. Okay, thank you so much. Have a good day.
Students, you can join the next session. 67. You can join the next session.